Hey everybody, John Norland here with a quick explanation about the difference between correlation and causation. First of all, what's a correlation? Well, sometimes starting out with an example or two helps students understand. Okay, so we see that whenever ice cream sales increase, shark attacks also increase. And this does this very predictably over time. Whenever one goes up, the other goes up too. Whenever one goes down, the other goes down too. We call that a correlation. Another example might be in one city, students in charter schools score higher on standard tests than students in regular schools. That's another correlation. So in general, when two things predictably increase or decrease at the same time, that's a correlation. Okay, so one thing to note is when both things go the same direction, like when one goes up, the other goes up, or when one goes down, the other goes down, we call that a positive correlation. The two variables sort of stay close together. When they go in the opposite direction, when one goes up, the other predictably goes down, or vice versa, that we call a negative correlation. Doesn't really matter too much for what we're going to talk about today. I'm just going to stick with positive correlations. All right. Okay. The big mistake is that people often wrongly assume that when two things are correlated, that it proves that one causes the other. It really doesn't. Well, so why is this important? Well, it's important to understanding science, but also as a citizen and as a person managing your own life. People make decisions like where to send their kids to school or how to vote based on correlations, and they probably, for the most part, should not. Okay, so let's take a look at our examples again. The big thing that explains why you can't assume that when two things are correlated, one causes the other is really the third variable problem. Okay, so let's look at the first hypothetical example. When ice cream sales increase, shark attacks also increase. Now, most of you wouldn't assume that ice cream sales cause shark attacks, that somehow the sharks smell the ice cream, or that somehow people swim more when they've got ice cream because they're stickier or something like that. Most likely, they both go up and down together because of the weather, because when it's hotter outside, people buy more ice cream. And when it's hotter outside, they swim more. Okay, so this third variable causes both. This is important because obviously, if the mayor of the town where this is happening outlaws ice cream sales, or if the city council, say, passes a law to outlaw ice cream sales, because they want to stop shark attacks, it probably won't work, right? It's not likely that that would have an effect. But quite often we see politicians or people behaving in this way, drawing these conclusions around correlations. Okay. Let's take a more practical example. For example, in one city, students in charter schools score higher on standard tests than students in regular schools. This is a correlation. Well, it could be, and actually we found that when we compare the scores of those who got into the charter schools, not with the whole regular school, but only the students in regular school who also tried to get in, okay? So it compares students that are a little more alike because their families or they themselves were motivated enough to try to get into the charter school. When we compare those two groups, their test scores, their average test scores are the same. So we find that it isn't the charter school that's actually causing their scores to go higher, but it's probably a third variable, something like parental involvement or motivation, that might cause both groups to have higher scores. Okay. So how could we then find out whether or not one variable causes another? Well, the key is we have to select those that are going to be in our research randomly, so that just as many people in each group have motivated or involved parents, let's say, as in the charter school example. So here's the key for your test and for your life as you apply this knowledge to your life. When the participants select whether or not they're in, right, when they select themselves whether or not they go to the charter school, that result is always a correlation. When the researchers randomly select and decide who's going to go to the charter school versus who isn't, that's an experiment, and that can help us prove or fail to prove that the charter school causes the higher score. One important note is that in scientific research, one can't prove a negative. In other words, one can't prove that something doesn't cause something else. One can only fail to prove that it does. Okay, that's sort of an important note. Now, I'm hoping that this little YouTube video, in addition to your textbook reading, in addition to the stuff that you're going to do through Psych Portal, is going to help you do better on the quiz, do better on your discussion questions, and have a better understanding of the difference between correlation and causation. Thanks.